Hello and welcome to today's episode of the Daily Space for February 26th, 2019. My name is Dr. Pamela Gay and I am here to put science in your brains. We have with us the dog cam. I need to not cut my arms off with the green screen. Shown in the dog cam is Stella. Eddie is actually underneath my desk staring at her forlornly because she has stolen all the bones. I don't have Cheerios, but I do have oyster crackers. And in case of bits, there shall be... Eddie, come on, over here. Okay, Eddie doesn't care. Stella cares. There will be the giving of treats to the dogs, and I'm reaching under the table to give out any some. So I am taking a lesson from Annie Wilson. So yeah, there's that. But the real reason that we're here today is to discuss science. The dogs are just an added bonus feature. In today's top story, we have a tale of a misbehaving baby star. Of course, all baby stars misbehave. It's what baby stars do. They flicker, they flare, they blow off jets, they basically stream material all around them. In this case, Alma was able to focus in on a baby star that had two different incidents of misbehavior in its past. This particular baby star, if you look at this image that was taken in radio waves by Alma, you'll see that there is a blue, tightly focused jet, and then there is a orange and red, not as tightly focused jet. These two jets of material are actually related to two different incidents in the star's past where it gave off a whole bunch of material in all different directions. And the cool thing about this is, if you look at it closely, you'll see that the blue jet isn't lined up. I am really not as good at green screening as I'd like to be. The blue jet isn't lined up with the red jet. It appears that during the two different points of stellar misbehavior, the star was actually lined up on the sky slightly differently, leading the blue jet to have one orientation and the red jet to have a slightly different orientation. This is the first case that we've had of this kind of a misalignment being zoomed in on. Alma is once again showing that when it comes to understanding how solar systems come to be, how stars form, and the planets around them take shape, well, it has lots and lots of surprises that it is going to uncover for us. Now, moving on to our next story. We don't have any details, but there is word that the Bereshit lander that has not yet landed, that is currently orbiting the planet Earth, had, right before it was supposed to fire its rockets, a system reset that was entirely unexpected. Essentially, what's happening is as Bereshit goes around and around the Earth, at certain points in its orbit, it's supposed to fire its thrusters. This allows it to go into a more and more elliptical orbit with each thruster firing until it eventually is able to break free of Earth's orbit and put itself in orbit around the moon. This is an extremely low energy way to make the transition from Earth to the moon. And when you're a little lander with not a lot of budget, well, this is the way you do it. Unfortunately, for unknown reasons, the system reset before the firing that was scheduled for today. The systems are all back online, things are going strong again, and it's believed that things will be fine from here on out, but it's not entirely known. So let's keep an eye on this together. System resets are not unheard of. We had to reboot the NASA Mars Curiosity rover just within the past couple of weeks because it also had, an issue on board. Sometimes you just have to get out and kick something, or in this case, send a power cycle, a reset, or some other kind of command like that. So, yeah, here's to hoping that everything else from here on out is clear sailing for this little Israeli lunar lander. We're all keeping an eye on you, Bereshit. Fly strong. Now, in other news, we have word coming to us from a series of different House subcommittee hearings that have been taking place in Washington, D.C. Jeff Faust and others have been directly reporting, and they made some comments that I just hadn't thought through what was going on. So Jeff Faust retweets Marcia Smith, who is tweeting for Space Policy Online. She points out that NASA's Paul Hertz at a... Hey. Sorry, the puppy decided that the puppy needed to beat up the senior dog. That was unintended. They are currently chewing different ends of the same bone. Okay, sorry about that. So Marcia Smith from Space Policy Online reports that NASA's Paul Hertz at a AAAC says that even though Congress gave WFIRST $312 million, that's $60 million less than what the project was planning, so there will be an impact. So this is news that the WFIRST spacecraft, which is being put together to study dark energy as well as to find planets and a variety of other space telescopy tasks. It needed a certain budget to stay on deadline, to get all of its instruments done, and in the negotiations between the president wanting to cancel it and Congress wanting it to still go, they found a way to keep the mission moving forward, but the way they're moving it forward is still significantly under budgeted. So they got $312 million. What they needed was $370 million. That is a significant difference by percentage. And now they're going to have to figure out how to keep going, or money from other parts of NASA's budget is going to have to go into this spacecraft. Now, that probably won't happen in this budget year, but what often ends up when you have a shortfall of funding at one point is that funding has to come in later. It's not like the need goes away. So one piece of good news was actually a piece of bad news. Marcia Smith goes on to say that Paul Hertz reported Congress gave astrophysics $310 million more than requested, but added $312 million for WFIRST. That means that there was a line item that $312 million needed to go to WFIRST. More for Hubble and Sophia and others. So with all of these line item adjustments, this actually turns out to be a $35 million cut compared to their plan. So what happened is they increased the budget, but then within the budget that Congress gave NASA, they said, you must spend this much for this mission, this much for this mission, and this other amount for this other mission. And when you add up all of those line items, what's left over for the budget for astrophysics is actually $35 million less than what astrophysics was planning to spend. And this starts to add up to lots of problems, especially when you look at other places where there are budget delays or budget shortfalls rather, and mission delays. Jeff Faust goes to point out that Fox says NASA Heliophysics is looking at ways to take advantage of any rideshare launch opportunities as they arrive, including those that may appear on short notice, what capabilities they can put into the heliophysics pantry that can be flown quickly. So here we have heliophysics is basically, okay, we're just going to piecemeal put things together as we can given launch vehicles, because there's now also a launch vehicle problem. This is coming up particularly strongly with the ICON mission. ICON has been delayed now for several years. This is a little mission that is designed to study the ionosphere of our planet Earth. It just needs to get into low Earth orbit, and it was slated to get into low Earth orbit onto an orbital ATK rocket that is dropped from an airplane. So an airplane flies up to 40,000 feet, drops the rocket at 40,000 feet, the rocket fires, takes ICON to low Earth orbit. This is meant... Hey! Okay, once again, the puppy tried to eat the older dog. Come here, Eddie. Aha, I see the problem. They are both trying to eat the same bone again. I threw them. Here, go. Go over there. Eddie figured it out. Here. Okay, continuing on discussing the ICON mission. So with ICON, this is a mission that was supposed to have launched a couple of years ago. It then got rescheduled for October, got rescheduled for November. At this point, it doesn't have a launch date. They're currently saying that it may be the second quarter of 2019 that it launches. And the problem is they keep having an electrical issue in the rocket. Now, this is a rocket that was used a lot during the 1990s, but hasn't actually been used since 2016. So this is older technology that is being used on a significantly delayed mission, and we're no longer sure when it's going to be able to launch. Now, all because the mission, which is complete, is waiting on its rocket, doesn't mean it doesn't have costs associated with it. There's storage costs, there's clean room costs, and they have to keep checking up on it. So ICON is having budget delays. We're also looking at the Mars 2020 rover is over budget, and there's discussions about it potentially being delayed 2 years. And I'm going to fix this. Guys. Okay, no more dog bones for them. They get to sit and stare at me and hope for oyster crackers. Because the puppy doesn't know how to behave or share. So anyways, there are a lot of budget issues going on. And as we look at NASA getting a larger budget this year, what that means is all of the cost overruns that are currently taking place will get absorbed somewhere. But the overall budget available for grants and other projects is still going to be diminished because there's only a finite number of resources. And when one set of programs runs over budget, that means everything else gets asked to be under budget. So this is what happens. Anyways, that concludes all of the news I had planned for today, and I will now take your questions. While you type those in, please remember to @CosmoQuestX so I can find them in the chat. And while you're typing them in, here is our standard station identification. The Daily Space is part of CosmoQuest. We are your place to learn and do science. You can join us here every Monday through Friday, or at least most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We will bring you all that is new in space and astronomy. And because I'm saying I'm going to remind you all that tomorrow, which is Wednesday, Annie Wilson will be hosting this show, and will probably be bringing us more fabulous rocket updates. She is also here every Sunday, same time, same channel, bringing you the Sunday Science Hour. In addition to these regularly scheduled shows, we also bring you random launches, landings, and other real science as it happens. So give us a follow and get notified whenever we go live to bring you all that is new coming to you from the universe we all share. We are part of the Planetary Science Institute, working in collaboration with Youngstown State University. We are here thanks to the generous contributions of people like you. We are sustained through your subscriptions, and every bit really matters. We are a 501c3 nonprofit dedicated to, science exploration. So thank you for all that you do, and I am now going to take your questions. Let's see what we have. Fenring, thank you. Okay, come on, dogs. Go over there. There, I made it rain oyster crackers. Thank you. They both are getting some. They went all over the place. So thank you for the bits. Okay, so House of Steve writes, this might be where I can find more info sort of question, but I was watching Katie Mack talk at CERN yesterday about the dark energy causing the heat death of the universe. Oddly enough, the Discovery Channel talked about the same thing, but they mentioned that somehow, if dark energy keeps expanding things at some point, things can turn around and collapse again. I missed the part about how phantom dark energy expansion can turn around. So if the amount of dark energy isn't constant and it ends up diluting in the future so that it stops accelerating the universe apart, if we have enough matter in the universe, then it is possible that the matter will overrun the dark energy as the dominant force. The way we talk about this is, are we in a dark energy dominated universe or a mass dominated universe? If the universe is dominated by mass, then there's the potential for all that gravity to slow the expansion until it stops it and eventually recollapses the universe. If we're in a dark energy dominated universe, we're just going to keep expanding, and that expansion is going to keep accelerating. We're still trying to figure out exactly what dark energy is and how it might be changing with time. We had thought observationally for a long time that dark energy was completely consistent as a function of time. This meant that for every cubic meter of universe that we had, the amount of dark energy per cubic meter was the same no matter what size the universe was. And we don't know how to explain that being a thing. Within the past couple of years, though, we've been seeing discrepancies in the measured expansion rates when we use techniques that look at the expansion rate in the most recent parts of the universe, and when we measure it using observables from the earliest parts of the universe. It was a small discrepancy, but enough of a discrepancy that the error bars on the measurements didn't say this was just an error in measurement. It seemed to be a real discrepancy. Recent observations that looked to use gamma ray bursts as a method of measuring distant galaxies' accelerations seem to be pointing that there actually is a change in the amount of dark energy as a function of time that we hadn't been able to detect before. If this measurement proves out through further observations, through further techniques, it means that we can consider futures where the dark energy also isn't constant. And that non-constant dark energy means that pretty much anything is possible once again. Now, most likely, everything is pointing towards we're just going to keep expanding. The mass density, the energy density, all of it points to we're going to keep expanding. But when you're dealing with a television show, you're not interested in just what is most likely. You're interested in what is going to get the most viewers to your television show. So they're going to look at some of the more unlikely outcomes of the expansion of the universe. So I hope that worked. So Super Cowboy 75 is asking, do you know what happened to the Mars rover Spirit? Yes, little Spirit got stuck in the sand at an unfortunate tilt and didn't survive through the winter after it got stuck because it just couldn't get enough solar energy onto its panels. For a while after it got stuck, they were actually using it as an observational station to observe the sky above Mars. It did some really cool work even after it got stuck. Unfortunately, they need the rovers to be at particular angles relative to the surface of the planet to get their solar panels maximally illuminated when it's cold and dark outside during the winter months, and that just didn't happen. Okay, scrolling back, looking for something less sad. And both dogs are now asleep on my feet, or at least lying on my feet. You can see Eddie's butt. Okay, scrolling. So Henny's Warverb asks, how does anything get done with this random budgeting? Don't things get more expensive the more they are delayed? Yes, they do get more expensive the more they are delayed. Yes, they do. So what ends up happening is people like me get our budgets cut and have to fire a lot of people, and projects go away. They generally make the cuts on grant programs. So if you have a spacecraft, you can only cut things so much. You need people to operate the spacecraft. You need people to listen to the spacecraft. So infrastructure like the Big Ear keeps going. The Deep Sky Network keeps going. You still need to pay heating and cooling, custodial, all of those sorts of things. And so when you've cut back everything you can and you still have to make cuts, you look to the grant funds. These are people like me who do research but work for other institutions and are funded to answer specific research questions using NASA funds. Our project CosmoQuest was funded from 2012 until December 31st, 2018, off of a whole series of different NASA grants. And I had previous NASA funding going back to 2009. Now, currently I have very little funding because our largest grant, we were told last August, might get cut due to James Webb Space Telescope overruns. And we were told in October, yeah, we're getting zeroed. So that's what happens. That's what happens. So, yeah. And yes, she is a teen dog now. So Refs Matt asks, is the budget doing good things for NASA education at long last? It's now called Science Activation. And I haven't looked. I have to admit that's kind of a source point for me right now. So yeah, I didn't look. Scrolling back. So yes, Larry, Weird and Proud. In the image of the baby star, we are looking at the blue tight jet and the red less tight jet are slightly different radio frequencies. We think that the less tight jet occurred first, if I read the paper correctly. Let me pull that up real fast and double check before I inadvertently lie to you. Hold on. Sorry. So in this case, the orange and the blue refer also to the speeds. So the blue is faster, the red is slower. This is what is causing them to have different frequencies, different wavelengths. Sorry, I'm trying to figure out. So I'm not finding this quickly in the article. I will share it in the chat so that you can chase down additional information rather than watching me chase down additional information. There we go. Okay, I'm sorry if there was just some sort of a weird flicker. Oh, I just put that in chat on a different Twitch channel that is probably greatly confusing. Let me find the correct window for this stream's chat. There we go. Okay, so I'm going to scroll back down to the bottom and see what other questions there are. So Ed Thompson asks, is there a lobbying group in DC for science educators and researchers, or are you left without someone to lobby Congress? So we generally do it for ourselves. Scientists go in and we lobby for ourselves. Our professional societies do help. The American Astronomical Society has an intern. The Planetary Society, which you can donate to, does a good deal of lobbying. Most of the lobbying does go into saying we need more science funds. And so we are somewhat on our own. So Henny's Vorverb asks, has there ever been a push to have NASA budget done on a multi-year basis to maybe even things out? So they do try to budget on a multi-year basis. The problem is that Congress can change their minds. So they plan out, okay, so we're going to budget this amount, we think, for the next 5 years for this grant, for this grant, for this mission, for this mission. Those are the intended budgets. And then each year those budgets have to be adjusted based on what Congress does. They do what they can to reduce budget with oncoming programs. So if you have X amount carrying over from the prior year that you had planned to spend and the new budget comes in less, you try and protect the old budgets and not start as many new things. That isn't how it's always done, but that is one of the things that tries to get done. So Henny's Vorverb asks, would the dark energy change in the entire universe at once? We don't know. We just don't know. There's lots of things that we just don't know. Yeah. Okay, are there any other questions? Anyways, so thank you all for being here. I am going to, just because I can, offer my dogs, come on out, offer my dogs oyster crackers one more time to hopefully get them back onto camera. There they are. I am going to be going and getting Cheerios, and when you donate bits, the dogs will be getting Cheerios, or today, oyster crackers. So thank you all for being here. If, there's more questions. The Raven Lillian asking, is not science, but what's the senior dog's name? So the bigger dog, the older dog, that's Eddie. The smaller dog, who's still a puppy, is Stella. My husband named both of them. Eddie is named after a character in Nurse Jackie, and Stella is just Stella. Actually, Stella is Stella so that we can stand on the patio and yell, Stella, like out of a book. So, yes. Thank you all for being here. Once again, this has been The Daily Space. Tomorrow you can come in. Thank you, House of Steve. That's amazing. All the oyster crackers, all the oyster crackers. Okay, they get all the oyster crackers. Thank you so much. That's fabulous. Yay. I will add more. Here. Trying. I am not graceful. I want you to be able to see them as they enjoy these. Let's see. I'm putting my camera up on a stand and apparently trying to drop it into my coffee. Let's not do that. There. See those faces? Those are the faces that you just made happy. In addition to my face. So thank you. Okay. This has been The Daily Space. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are here most Mondays through Fridays at 10 a.m. Pacific. That is 1 p.m. Eastern, 6 p.m. London time. Join us to get a fresh look at all that is new in space and astronomy, and fuzzy dogs. We are here because of you. We are supported through the generous donations of people like you. Your subscriptions sustain us, and every bit really matters. Thank you for being here. Tune in tomorrow for Annie. I will be back on Thursday when we have special guest, Dr. Bill Hartman, who's a planetary scientist. And, well, he's a space artist that inspired me when I was a little kid. So I can't wait to have him here and share the interview with you. So I am now going to roll the credits, and then I am going to raid Oh Bother, who is doing makerspace work, and it's a good day. So, pardon me while I find the credits to roll, and there may be random streams later today related with coding. I don't know. I never know if that's going to happen or not. So, wherever you are in the world, have a fabulous morning, evening, afternoon, and if the weather allows it, get outside and look up. Bye-bye.